Okay, in part 5 here, I'm going to do this one. So it says combine expressions by writing them as fractions and finding a common denominator algebraically. Again, it's usually best to rewrite everything in the problem in terms of sine and cosine. If you have a square involved, look at your Pythagoreans first and then simplify. But if you don't have any squares, it's generally best to write everything in terms of sine and cosine. So secant, I'm going to use theta instead of x. Secant theta is 1 over cosine theta times cosecant theta is 1 over sine theta. Subtract cotangent theta is cosine theta over sine theta. That's using the reciprocals. We use this section here, and then the cotangent one is this one right here. That's what I just used to simplify so far. So combine this together into 1 over cosine theta sine theta, just multiplying the denominators there, minus cosine theta over sine theta. So we want a common denominator here. Well, this one is cosine theta sine theta, this is sine theta. So we ask ourselves, what is this one missing that this one has? Well, it's missing a cosine theta. We need to multiply each piece by 1, by a form of 1, so we don't change the value. So we can get a cosine theta here by multiplying top and bottom by cosine theta. This part in pink is just equal to 1. This is equal to 1. It's okay to do. So then I get on top 1 minus cosine squared theta. That's this one minus those two multiplied together, all over our new established common denominator, which is cosine theta sine theta. That's because we did this work right here. Remember, it doesn't matter if I write cosine theta sine theta or sine theta cosine theta. It's the same. Your two things are multiplied together, the order doesn't matter. So I'll just leave it cosine theta sine theta. And if you look at the Pythagorean identity, the primary one, this one right here, and you rearrange this, I can use it. So I'm going to write this out and then show it rearranged, and you'll see another way we can use it. So the original, coming over here, the original identity is this: sine squared theta plus cosine squared theta equals 1. Right now I have this, so I'm going to make this, I'm going to rearrange it and make it look like this. So I'm going to subtract the cosine squared theta over here, and I get sine squared theta equals 1 minus cosine squared theta. So in other words, 1 minus cosine squared theta is equal to sine squared theta. So that's what I'm going to do here. 1 minus cosine squared theta in the numerator becomes this, sine squared theta, using rearranging the Pythagorean, primary Pythagorean identity over cosine theta sine theta. Okay, then we simplify. This sine theta goes with the square part there, so we're just left with sine theta over cosine theta. And from the quotient identity, sine theta over cosine theta is tan theta, and we are done. No fractions, and in terms of one trig function. So final answer there, tan theta. Okay, section 6. Rewrite each expression as a product using a greatest common factor, then simplify. So I'll do part B here. So if we look at part B, we have cotangent b's in common there, so we're going to factor that out. So cotangent b outside, and we would be left with secant squared b subtract 1. If we distribute that back in, we'll end right here where we started, so everything is equivalent. Notice we have a squared term, so we should be looking at our Pythagorean identities. So I'm going to use this one right here, 1 plus tan squared x equals secant squared x. So I'll do it this way: 1 plus tan squared, I'll use theta, equals secant squared theta. That's right off of that identity sheet. So if I subtract this 1 over here, I'm going to get tan squared theta equals secant squared theta minus 1. I'm just rearranging this identity. Well, that's exactly what I have right here. So it's just tan squared theta. So I end with this cotangent, or next step I end with this. Tan squared b, we're using b as our angle here. So I have cotangent b times tan squared b. Well, let's rewrite everything in terms of sine and cosine. So I would have cotangent b, same thing as cosine b over sine b, times tan squared b is the same thing as sine squared b over cosine squared b. So that's just using squaring this quantity right here, squaring that. Sine, if you have two of these multiplied together, it's sine x times sine x over cosine x times cosine x, which is sine squared x over cosine squared x. Okay, now cancel what we can cancel. One of these goes with the square here. One of these goes with the square here. So I'm just left with sine b over cosine b. And using the quotient identity, that's tan b. So final answer there, tan b. Okay, part 7, solving trig equations. Simplify the expressions used in each equation, then solve on an interval from 0 to 2 pi. So in other words, solve it on the unit circle. So I'll do this part B here. So I'll rewrite everything in terms of sine and cosine to start with. So we have cosine x, tan x is sine x over cosine x. And cosecant squared x is the same thing as 1 over sine squared x, which equals 2. So then let's cancel what we'll cancel. This cosine x goes with that cosine x. This sine x goes with that square there. So I have this 1 over sine x equals, I'll put it over 1. So 1 over sine x is the same thing. We could do this. Cosecant x equals 2 over 1. So if cosecant x is 2, then sine x is the reciprocal of that. So sine x equals 1/2. The reciprocal of cosine is sine. So if cosecant is 2 over 1, then sine is 1/2. So what we're asking here is at what angles on the unit circle is the y-coordinate, because we're talking about sine, equal to 1/2. So if we make a quick reminder sketch here of the unit circle, 1/2 for the y-coordinate would be the two lowest legs here. That's the only place where it's positive 1/2. It's negative 1/2 here and here, but we don't want those. We want positive 1/2. And that's the lowest leg in the first and second quadrant. So pi over 6 and 5 pi over 6 gives us a y-coordinate of 1/2. So the answers are x is pi over 6 and 5 pi over 6. So we have two answers there. So those are our solutions to that equation. All right, last part here, part 8. Write each equation in terms of only one trig function, either by replacing sine squared x with 1 minus cosine squared x or cosine squared x with 1 minus sine squared x. So that's just using the primary Pythagorean identity. That's this one right here, just rearranging it, that's all. Then use factoring to solve the resulting equation on an interval of 0 to 2 pi. So I'll do this one right here. So I'm going to replace this cosine squared x with 1 minus sine squared x. I'm doing that because we already have a sine x in the problem, and that seems to make the most sense. So 2 times, instead of cosine squared x, I'm going to use 1 minus sine squared x, plus sine x minus 2 equals 0. So this piece right here became this piece right here. That's all I've done so far. So distribute in here. So we get 2 minus 2 sine squared x plus sine x minus 2 equals 0. Well, this 2 and this negative 2 cancel each other. 2 minus 2 is 0, so those cancel. And so I'll write what's left. Sine squared x plus sine x equals 0. So greatest common factor here, we can take out a sine of those two, sine x out of those two terms. So sine x outside, and we'd be left with negative 2 sine x plus 1 equals 0. So we have two factors. We have factor 2 there and factor 1 here. So we're basically solving two equations at this point coming over here. So we have sine x equals 0 when, that's one of them. And then the other factor was negative 2 sine x plus 1 equals 0. So that's what I'm solving. So let's do this one first. So when is sine, in other words, what angle on the unit circle is the y-coordinate 0 in the interval from 0 to 2 pi? Well, the y-coordinate is 0, make a rough sketch of the unit circle, here and here. So that means that the answer here is 0, and the answer over here would be pi. So there are two answers. So far we have an answer of pi and an answer of 0. That's coming from this one right here. Now we need to solve this one. So we subtract 1 from both sides, and we get this, negative 2 sine x equals negative 1. Divide by the negative 2 there. We get when is sine x equal to positive 1/2. That's similar to our earlier problem. So in other words, what angle on the unit circle is the y-coordinate 1/2? We did that in the previous problem, and that was at pi over 6 and 5 pi over 6. So we have 4 total answers there. The angles, the answers are all angles. It's pi, 0, pi over 6, 5 pi over 6. So 4 total answers there. So that is it for this video. Make sure you spend time on these identities. The more you practice, the easier it will get. In the beginning, you're going to find it difficult, and that's reasonable. It probably should be. But the more you practice, the easier it will be.